In this video, we're going to look at problem 4.17 from your Turbo textbook, and the signal, the periodic signal that we're interested in finding the Fourier series of, has some positive going pulses. So from -1 to 1, it goes up to 1, and from 7 to 9, it goes up to 1. But it also has these negative going pulses here from 3 to 5, for example, where it's -1, and then here from -3 to -5, where it's -1. And we're interested in finding the Fourier series. So if we look at this, the period of this is 8, so the fundamental frequency is 1/8 hertz, right? What else can we say just from looking at it? Well, the signal has 0 average value, so A0 must be 0. It's an even function, so that means that all of the B terms must be 0, and so we're left to find what the AN terms are. And so we can do that just using our equation that we know for finding the A terms, 2 over the period, which is 8, and then we'll want to integrate from -1 to 1, and the function has a value of 1 there, times our cosine from our orthogonal set. And then we have this other piece in the period that we're looking at that's non-zero from 3 to 5, and it has a value of -1 there, and then again the cosine function. So we can very easily do the math here. Integrate a cosine to get a sine function. And what we'll see is a sine of pi n over 4 is equal and opposite to a sine of pi to the minus 1 over 4. It's an odd function. And so these are actually going to turn into, well, we can write it out, sine of pi n over 4 minus sine of minus pi n over 4. Minus sine of minus pi n over 4 is equal to sine of pi n over 4 because it's an odd function. And then we also have sine of 5 pi n over 4 minus sine of 3 pi n over 4. And minus sine of 3 pi n over 4 equals sine of 5 pi n over 4. And so we have 2 pi n sine pi n over 4, so this term, plus 2 over pi n and sine 3 pi n over 4. If we look at this, it's 0 for all even n, and for odd n, sine of 3 pi n over 4 is equal to sine of pi n over 4. So we have 4 pi n sine pi n over 4 for n odd. So that's how we find the trigonometric Fourier series coefficients for the problem in Turbo 4.17.